These are images from the Mars Global Surveyor, taken, as you can see, not too far apart. This was the season of an immense dust storm, and you see the clouds, all this structure. So very little atmosphere other than dust that interfere with our observation. But Mars is interesting because it's actually only 50% further away from the sun, so it's close to this habitable zone. It's about half the size of the Earth, but it gets less than half of the energy from the sun. But its most unique characteristic is that it has temperatures that are as high as 45 degrees Fahrenheit. 45 degrees Fahrenheit. That makes it above freezing. So we could, in fact, have liquid water. However, because it has no atmosphere, it doesn't have any greenhouse effect. And so what happens is, at night, it goes down to minus 200 degrees Fahrenheit. So if the water exists, it freezes overnight and melts in the day. So very interesting. But again, this is mainly the reason why Mars is the target of many, many missions and searches for possible past or present life. Mars also has, as I mentioned, no atmosphere. And because it has no atmosphere, what happens is you have no layer, such as ozone and clouds above, which maintain warmth down here, and ozone, for example, which protects us from damaging ultraviolet radiation from the sun. Whereas on Mars, because there is no, by the way, I should explain, this is altitude and this is temperature. So this curve actually says as you go higher up, it gets colder, and as you get even higher, it starts to warm up. And this region is called the stratosphere. The ozone is what basically absorbs the energy from the sun in this ultraviolet and then emits it in infrared. So it keeps us warm and protects us from damaging light. Now on Mars there's no such thing, although there is ozone, which plays a different role. Also the topography, you see this is Mount Everest, and this to scale is Olympus Mons, which is a mountain on Mars. So it has a much greater topographic relief. Anyway, we know what Mars looks like now. These are the two rovers, Spirit and Opportunity. This rover you see landed here. I've seen kind of nice location. And this, where Opportunity landed, you can even see street signs, see? And we also have, we've been to Mars. This is our engineer, John Hannon. Now, doesn't it look exactly the same as up here? Right? I mean, it's the same. In fact, this is on the Earth, and this is where it is. It's on the top, it's in Hawaii, of all places. It's in the top of a mountain called Mauna Kea, and the Mauna Kea Observatory houses the largest telescopes in the world. These two telescopes here are 10 meters in diameter. So the mirror on these telescopes is bigger than this room. There are two of them. There's the Subaru, which has an 8.2 meter telescope, and the Gemini. The Subaru, by the way, is the National Astronomical Observatory of Japan, and this is Gemini is an 8 meter telescope, which is a consortium of North, South American, and European institutions. And the IRTF, the Infrared Telescope Facility, it's only 3 meters, but it's a NASA telescope, and we love it. In fact, we love it so much we go there. That's what it looks like. This is us. See, we hang instruments at the end of this telescope. This is 3 meters across, and we can mount our instruments. And you see, you have the students working, and the senior civil servants walking around with their hands in their pocket. And here you have the outside of the telescope and the entrance. In 1997, the Cassini mission, a joint mission between NASA and the European Space Agency and also the Italian Space Agency, was launched. It consisted of a fairly large spacecraft with a probe called Huygens probe, built by the Europeans, that was to enter the atmosphere of Titan. And the actual spacecraft would continue orbiting around Titan, and has been orbiting now for 4 years, over 4 years, and the mission has just been extended for another 2 years at least, and they'll be asking for a further extension, because it's a phenomenal scientific laboratory that continues to work. But the probe was a one-time deal. The probe was going to be released, and so we wanted to be there. Not there physically, but at least go to the Japanese Subaru telescope to observe Titan at the same time as the probe is released. Well, welcome to Hawaii. Where do you see the palm trees and the beaches? Hawaii. We couldn't make it to the summit because there was too much snow. And in fact, at this altitude, which is 14,000 feet, 4,000 meters, the temperature is such that you get substantial amount of slope. Mauna Kea, by the way, in native Hawaiian, is White Mountain, and for good reason. Here's a satellite image of that particular day of the descent of Huygens probe at Titan, and we're over here. And so these are the two shield volcanoes that make up the island. This is Mauna Loa. This is actually an active volcano. You can see some of the activity down here. This is and this is Mauna Kea, which is the White Mountain, and beautiful White Mountain. We couldn't drive up to the telescope. We walked over 100 meters, and if anybody has gone up a hill at 14,000 feet for 100 meters, I couldn't make it. And I used to run for distance. You can ask my friend Gene. So, but we fixed that. I got my guys, and we got shovels, and we cleaned the road.
That's what graduate students do.
And actually, the PI, the principal investigator, just gives instructions. And then we made measurements. And we made measurements of ethane on Titan, and from this we could get information about the wind. We looked at the one limb, the other limb of Titan, and there's such a thing as a Doppler shift, which changes the frequency, and I'll say a little more about that, depending whether the object is approaching you or receding. It's like a train. You hear a train whistle approaching, it's a shrill whistle, but when it recedes, the frequency goes down. So it's a high pitch, low pitch, receding, and that's a Doppler shift. So that's the same idea. This is if the wind is going globally around, we measure a higher frequency on this side and a lower frequency on this side of the same lines, and you can see these minute changes, and from this you can deduce how fast that wind is and also in which direction it's going. And we found that it was a global, like a jet stream on the planet, going from east to west. And of course, after the run, we had fun. My colleague here, Tim, is coming down on a shovel. I don't know if you can see the handle, but something that you don't know is at the end of this run is a several 100-foot drop. And this is how you dress up there when you work. Again, very Hawaii type.